But at least I got the radio mic this time so I can wander around without breaking the microphone. Cool, okay, we are at 5 past. Welcome to week 2 of COMP1511. I hope everyone's had a good first week at uni so far. How are the first tutorials? Hands up if you learned something new in the first tutorial and lab. Oh, good. Heaps of people learning something new. That's good. Hopefully you've met some people. You've met your tutor at least, and so you've got some people you're working with now. And actually, hands up who ended up going to Lab 0. I did see a lot of people there. I had a lot of conversations with people there. Okay, that's good. If you haven't gone to Lab 0, we put some of the notes in the week 1. I think we put it in the lectures section. I don't know because Tom put it there. It's either in the lecture section or the tute section. There's Lab 0 there. If you want to have a look at that, it's basically... it's not exactly like the labs that we do, but it gives you a lot of these little exercises that help you a little bit in just sort of getting acclimatized with UNSW in general and CSE and how to use all the bits and pieces that we put together for you. Because when it comes down to it, there's lots of distinct parts in everything that we're doing. And so the uni has got a big kind of umbrella administration over everything. And then there's the engineering faculty, which we're under the computer science school and stuff. And at every level, there's sort of different levels of organization. So it's good to at least get a quick look at what they all are so that you get an idea about how you're going to navigate this place. Because I think most people are probably coming from schools with, say, I don't know, I'm thinking like 3,000, 4,000 people. Like the biggest schools in Sydney have got like 4,000 or 5,000 students at most, I think. And here we're looking at an organization the size of a suburb that has something like 30,000, 40,000 students to begin with, and then like a lot of staff as well doing things. So it's nice to sort of get your bearings at least so you're not completely bamboozled by the size of the organization and everything that's going on. Okay, let's launch into what we're talking about. So, what did we learn last week? I'm just going to do a quick recap of everything. Actually, I've got some slides of the recap, so I'm going to go through. But we covered a lot of the basic topics, and just in terms of sheer quantity of what we went through, there's lots of little pieces that we put together last week to make a program as such. And what we're going to be doing this week is, for today, I'm not going to necessarily introduce anything new technical, but what I'm going to do is go through most of them again, use them again in a different way. And I wanted to talk a little bit about generic problem solving, because it's good to have a decent approach to how we're going to crack problems in general. And that way, if we can't immediately figure out what we want to do with something, we can always sort of try to fall back on a particular technique and see if it works. So I just remembered I didn't actually turn on the air conditioning. This could get pretty messy otherwise. It's pretty hot today. Okay, so here's a list of everything we did last week. I'm going to go through some slides and talk about it. And what we're going to cover today is a bit of a recap of some of the stuff I gave you last week, because I'd say Wednesday's lecture was like a big shotgun where I just went, boom, here's all these topics. It's like those t-shirt cannons. Oh, I'm going to get a t-shirt cannon. That'd be great. Fire off CSE t-shirts at people or something. I think it'd be a lot of fun. We need to like change all the lectures into like late night talk shows and stuff. I can bring guests on and just make fun of them and put on skits and stuff. I think that'd be a lot of fun. I don't know if you'd learn anything, but it'd be a lot of fun. Okay, so we're going to look at some more construction of things like if statements and stuff like that. Last week, just for a little bit, I showed you this thing called modulus, which was going to allow you to divide things and find out the remainder. We're actually going to use that this time. Actually, are we going to use that? I can't remember where I put that. I think I'm going to use that. I did look at these slides like yesterday, but I forgot exactly what was in them. But we'll try to look at some of the things we didn't look at in great detail last week. And we're going to continue with the dice checker example that we did last week and just add a bit more nuance to it. The other thing that we're going to look at today is a bit of problem solving, but we'll get to that when we get to that. Okay, recap. One of the first things we looked at last week was variables. Variables being ways that we can ask our computer to remember things for us. So this is data storage. This is our ability to say, these are the things that we would like our computer to keep track of Usually they're values that we're just going to store in there, and for the moment, the only ones I've taught you are numbers, which are integers and doubles. Integers are whole numbers, so they have no fractions. Doubles are floating point numbers, so the doubles are able to store things like halves and like a tenth of something, you know, that kind of thing. And they have a certain level of precision. So both of these have limits, so we need to remember that ints have an upper and a lower limit. Doubles do have a limit for how precise they can be, so they can't completely precisely store something like a third, because a third is an infinitely repeating number, and computers don't have an infinite amount of memory, so they're always going to run out of memory at some point when we're using them. When we're using variables, we try to give them a name, which means we would like them to be meaningful. We would like them to be something that we're not going to trip ourselves up with later. So it's a name that we're going to be able to remember when we go back and look at it. And we've got all this code happening on our screen, and this is a little bit of it. It's like, what's variable x? And you don't want to have to remember what variable x is. You have to go back up through your code looking for it. If the variable says, for example, last week, die 1, it's like, oh, that's probably going to be the value of the first die, so I don't have to think about it too much. They're called variables because we can change the value. We can also have constants as well. We're going to look at them again a bit today. The way that we're doing them for the moment is using this thing called hash define to say, okay, this is exactly the value of this thing, and then we can keep that for the entirety of the program. We also looked at reading and writing to the terminal. So the first thing we did was a really simple hello world, where we just did printf. We put the double quotes inside it. We said hello world, and that thing was going to display to the screen. We added to that on the Wednesday, we added the ability to take the value from a variable and display that variable to the screen. So if we have the %d or the %lf in there, that's where, in our string of characters, we were going to put the number. And then after a comma, we'd have the actual variable name afterwards. I'll go back and we'll actually look at code for these. I just wanted to just sort of bring all these concepts back up in your mind. Scanf was very similar to printf. Scanf has the capability of reading values into variables. And we had a look at maths operators. So the 4 at the top should be reasonably familiar to you in that those are representing basic mathematical symbols. I mean, the multiplication probably wouldn't normally be an asterisk to you, and the slash is for a divide in the same way that you can have a number over another number, and that's a division. They're going to work pretty much the same way that we expect them to work. They are going to go in order of precedence the same way that you would if you were doing them in maths. We can change the order of precedence if we want to by putting brackets around things to force them to be evaluated before the other things around them. The new one, which is one that we don't necessarily see very often in normal sort of pen and paper maths, is the modulus. And the modulus is just going to give us the remainder if we were to divide one number by another number. It doesn't actually perform that division, so you're not going to get a result for the division. You're just going to get told what was left over. Then we started looking into the things that sort of, I guess they're more computer specific, although you will see greater than and less than and stuff like that in maths a lot. But computers, as I was saying last week, work a lot in ones and zeros. So everything in a computer is stored in bits. And a bit is a binary digit that has a value of a 0 or a 1. So computers tend to think very, very logically. They tend to think in black or white. There's only sort of 2 possible outcomes of any of these. So any of these greater thans or less thans, equal to or not equals to, they're always going to say I'm one way or the other. And so these are the way we can use questions to, in a way, control what our computer is going to do. So our computer is going to decide, I'm going to take one path or another. We're going to be able to give a computer branching options of what to do. And we do that by if and else statements. Let me just go back to these first before I'm doing that. So zeros and ones allow us to decide between things. And then we can even, while working in zeros and ones, work with these logical operators and, or, and not, which are made specifically to deal with the idea of true and false values. So and is true if both things on either side of it are true, or is true if either one thing on either side is true. And so with these relational operators here and the logical operators, we can build up rather complex questions. So I can say, let me say I want to look at all students who just finished high school at the end of last year. And so that's one question. And I want to see out of those students, everyone who went to school south of the Harbour Bridge. So south of the Parramatta River and the Harbour Bridge. And that way I could ask two different questions and put them together with something like a logical operator there and get a certain set of possible answers. And we're going to do that with controlling our programs. We're going to say, I want to look at every number between 1 and 100 that's even. I can ask two separate questions for that and piece them together using these logical operators. Now, using those, we're going to be putting them together into these if and else statements, and the if and else statements allow us to, in a sense, turn on and off parts of our code. So when we have an if statement, we ask a question in the if statement here. So this is some of the code from last week, plus a little bit that I gave you a challenge to see if you could do something where testing if something was a tie or not. This is actually the solution to that. I could have not just asked greater than or otherwise. I could ask greater than or, I could ask equal to, and then I could say everything else. So I could say if the total is greater than the secret target, then it says succeeded. Otherwise, if the total is the same as the secret target, I could say tied, and then otherwise I could say not. So if and else statements can be put together in chains like this. So I can say, if this is true, what's inside the curly brackets after the if statement will run. If it's not true, it goes to the end of the curly brackets and says, okay, what's next? If it has an else, it says, okay, if that thing was false, so if this thing failed, then we go to the else and we definitely run the else. And then we ask another question, if here, and then we follow on, and if that thing was false, we hit this else. So if we chain these together with these ifs and elses, what we get is a situation where only one of these things can run. Oops. Giving away the meme. Yeah, only one of these three things can run because I've chained them together with elses and ifs, which means that the total against the secret target will be checked, and then it'll skip to one of these three depending on the conditions under which one of these questions is true. As we get deeper into this, we're going to be building up more complex things. Oh, actually, some people probably already have. Those of you who are in the Monday tutorials, we set up a thing in the tutorials this week to do a couple of if-elses with some maths and stuff like that to give you a chance yourselves in the tutorial lab to build this up. So, spoiler for those who haven't had their tutorial, and those who have, you know exactly what I'm talking about. Okay, so problems and solutions. Something that I kind of wanted to talk about, because when we get into computer science in general and programming at a deeper level, at the beginning, at the moment, a lot of what you're learning about is what do I type in to make this thing work? So you're like, okay, we got to type in a line, and some lines need a semicolon on the end, and other lines don't need a semicolon on the end. And it's kind of like, oh, actually, hands up here, who's learned to speak a language? I mean, I know everyone has probably because you speak something, but if you've learned to speak more than one language, right? Especially if you've learned to speak your second language, that's cool, heaps of people. I apologize that I haven't. Well, I tried to learn and I was really bad at it, but I know at least half a dozen programming languages, so hopefully that's okay. They're not very useful for speaking in. One of the interesting things you do when you first learn a new language is, when you first learn a new language, you can't speak it, right? There's nothing going on there, and you're just tripping up over grammar. You're trying to get your vocabulary right and stuff like that. Where you are at the moment with C is probably going to be similar to that. I've given you a few words. I've given you if, else. What else did I give you? Main, return, int, double, stuff like that. I've given you a few words. You don't necessarily know the full context for those words. You don't necessarily know all the situations they can be used in, but you know a few, and you start to piece together your first few sentences. As you get deeper into stuff like C, you will be able to piece together those sentences easily because C is a very formal language, so it's actually really easy to piece together sentences from it. But the thing that you don't necessarily get is having those sentences make sense. So I could string together a sentence that was entirely grammatically correct in English and stuff. Logically, it's a sentence that has like an action and a noun and stuff. Sorry, I have to dig back to the last time I actually studied English, but you need a subject and a preposition. I can't remember, something like that, yeah. But one of the things that then becomes much, much more difficult than whether you can actually put the code together and make it just sort of compile is, did you write the code that made sense? Did you write the code that actually solved the problem that you were trying to solve? Or even to the point of, did you say what you meant? You know, because like we do this in English all the time, like which we have a concept in our head and we're really clear on that concept, and then it comes out of our mouth and you just go, that's not what I meant. Those are just other words, you know. And so this is one of the things that we need to learn with programming is, how do we get ourselves to the point where we can think of something? We can think of how we want our program to get around a problem, and then we can say, okay, now I'm going to translate this into the code that I know. And so this is actually, for some of you, going to be all that you do. So I know a lot of people, and I did this for a while, where the programs that we write are something like 3 weeks on a whiteboard and then a few hours of code. Because the idea of what we're trying to get the computer to do is so hard that we actually need to spend a whole lot of time thinking about it first. And so this is something where, for the moment, most of this course is just going to be, okay, how do we actually write stuff in C? But I wanted to at least spend a little bit of time talking about this, because this is what it's going to be like once we get deeper into things. And also, some of you are going to hit these problems anyway, just for the fun of it, in the assignments. Or in the challenge exercises in the labs. So some of them are going to start ramping up soon into some interesting devious challenges where it's not really about whether you know code or not. It's about whether you can think about a problem before you even write the code. So one of the things that we need to know is, like, what is the problem we're trying to solve? So a lot of the time our code's not going to work, or or someone's going to ask us to write code to solve a problem, and we're not going to immediately know what to do for it. So there's a few techniques, and there's one in particular that I want to teach you, which is like actually a really generic problem-solving technique. So it's the kind of thing that you can probably apply to a lot of different situations. But one of the tricks is just figure out what the problem itself is. So figure out why the code isn't doing something. We're going to talk more about that in detail when we get into testing code. Because you may have seen that, like, you have to run your code multiple times before you see what's actually going wrong with it. But we'll talk about that later. But I wanted to give you this one technique that works pretty well in general for problem solving. And it's one of the things that we can use to get our head out of a rut. So this is something that I see happen. Actually, I was about to say see happen with a lot of people learning programming, but it's not true. It happens to everyone who does programming in general. The way that we need to think in order to code something like C tends to tie our brain in knots. So it tends to tie our brain in knots and get us stuck on tracks rather than getting us thinking about all the possible solutions. So this is a good way of solving problems that should be able to work for you in many situations, not just in computing. So first thing is figure out what's wrong. Find out what's not going right in our program and what we might need to solve. Sometimes this is going to be given to you by someone else. Sometimes this is going to be given to you by the program itself. Or sometimes this is going to be given to you by you observing what the program's doing and thinking that it might not be working correctly. The easiest with these is my stuff doesn't compile, and I have been given a set of line numbers with which to find out where and why it doesn't compile. The next thing we need to do, once we've had a decent idea about what we need to solve, this isn't always going to be correct. But you kind of need to start trying to solve a problem even if you're not 100% certain of what it is. Because if it takes too long to find out what the problem is, then you kind of don't get to make any progress. But anyway, the next step of this is, what are our options? So given the problem that we have in front of us, we have a certain number of possibilities of what we can do to try to fix this problem. Or not even just try to fix this problem, just what's our wiggle room? What can we even do here? So, for example, it's nice because at the moment we have a very limited vocabulary in C. So I could say to you, I want you to do X, Y, Z in a program. I'm not even going to say what it is because I want you thinking kind of general here. So I want you to write a program that does something. The first thing you need to think about is what are the things that we can do in C and which one of those is likely to apply to this problem. So say, for example, I want you to add up the ages of everyone in this class. So you could think, all right, adding, definitely. We've got some maths, so that's one thing that we're going to do there. If it's everyone in the class, then we're going to need to type in a whole lot of numbers in a row, so maybe I'm going to need a lot of scanfs and stuff. And so you start to piece together what things you can use to potentially get around that problem. The next thing that we need to do is, if we know all the different things that we can do, let's figure out which ones of those are going to make sense for what we're doing. So look at the different options, and this is where we come up with, like, we need to get from here down to K17, the computer science building. And if we need to get there, what are our options? A, we could walk down there. B, we can go up to Randwick and get a bus that goes around the bottom of the uni and then get off there and walk back into the uni. C, we could go to the edge of uni and call an Uber and get it to drive us down there. So the options are getting more ludicrous the more I go into this. We could find the biological sciences building, steal an animal there, ride it down to K17. So we have lots of different options, and some of them are viable to different levels. Don't go steal an animal from biological science. I don't even know if they keep animals on campus. But we can look at our options and we can decide how well do each of these options apply to the problem. So some options will 100% solve the problem that we have, but they may not be feasible for us to do. So if every time you needed to move between two buildings on campus you called an Uber, I think you're going to run out of money pretty quickly. Although it's going to be cheap because they pretty much drop you off where they picked you up. But you're going to run out of time and money doing those. So there's a question of, can you actually make an option work and can it solve the problem? And what we're looking for is an option for solving a problem that is both going to be easy for us to do or capable for us to do, even if it's not easy, and we think might solve the problem. The next thing we do is we start trying these things. So we start saying, okay, if I thought that I needed to, for the example of grabbing everyone's age, I need to like type in everyone's age. So let's start writing some scanf code and stuff like that, or let's grab a bunch of variables and say these are the variables we're going to put people's names in. We can start writing code and say, okay, does this work for one student? Okay, works for one student. Does it work for 2 or 3 students and stuff like that? And then you sort of build up your solution to a problem as you go. And as you do that, you test all of your sort of candid ideas of what it was you're trying to do to solve the problem. The next thing you need to do after you have solved said problem, or you have written something that may or may not solve the problem, is you figure out whether it did or it didn't. And so this might be the fact that you've written down previously what was going wrong, and then you test your code again with the same issues that was causing it to go wrong, and you see whether it's fixed them or not. Or you run the code again, and then you get a new set of problems. That happens a lot. And then you see differently how things are working. So the trick is that what we want to do is not get caught up unable to solve our problems, and say if we can use a process like this, we can kind of just follow it step by step and see what happens. Obviously what I've put up here is like super vague, but the beauty of it being super vague is it will kind of solve every problem that you have in computer science. It might take forever to do it. It might take longer than your lifetime to do all of the study necessary to get all the way through this process for certain problems. There are problems that have taken the computer science field like 40 years and we haven't finished yet. So maybe it's not perfect, but for a lot of the things you're going to, everything you're kind of going to see in COMP1511, there's nothing in COMP1511 that you can't all solve eventually, if you had enough time, if we gave you enough time to actually do it all. So say we did this course over like the whole year instead of just the first term, you potentially would have enough time to get 100% in the course. But what you want to do is not get caught up in situations where you burn a whole lot of time not being able to solve stuff, and instead you can use processes like this to sort of kickstart your memory, kickstart your thinking, or just get you off a track that you're stuck on that isn't solving things. So this is something I think that's going to come up a lot more in the future, although I think that even in this week's lab there's going to be questions that people can't just immediately solve. So I reckon going through this kind of process is going to be quite nice for thinking about how to do things like that. Okay. So talking about problem solving, let's think about the dice checker application that we had last week and what kind of problems we might have. We're going to look at one problem in particular and then see what we might do to fix it. So if you recall, the dice checker was going to ask people to type in 2 number values for dice. And those 2 number values are going to get added together, checked against a secret number, and then we're reporting back whether the roll succeeded or failed based on whether it was higher or lower than, or higher, was it higher than or equal to, or lower than a particular number. So one problem that we might get in this situation is what happens if our user, our game player who's using this app, types in a number that doesn't make any sense. So what if they type in a number that is higher than the range of the dice that we have? Or they type in a number that's lower than the range of dice, so they type in a 0 or a negative number or something like that. And we get really confused because then we get results coming out of this that don't make any sense. So what we need to do is figure out what exactly that problem means to our program and what are our options for trying to solve it. What I might, hang on, let me just open up VLab. And we'll have a look at the code itself. Oops, there we go. A little bit of Linux again. So I'm going to do ls to have a look at my directories and see what's in there. I've got my COMP1511 directory. Looking in here, I've made them already because I was prepping the lecture slides for lecture 3 and lecture 4. So I'll just go to lecture 3. CD changes directory to lecture 3. ls to see what's in there. Okay. So I made a starter file for the dice checker so that we can continue without changing the old file. If anyone wants to follow along, the exact file that I've got here right now is in the lectures section of the course website. So gedit, dice checker, I'm going to press tab to autocomplete. It's going to make it easier for me to do things. The and is going to allow me to keep my terminal running while my gedit window is running. Okay. And this is going to be pretty similar to what we saw at the end of last week. I did continue this after the lecture, so I've got a video that's up in the lecture section. It's on a little YouTube channel that I made for this course as well, so you can see that. And there's actually some old stuff in there as well if you want to, but it's a bit patchy because it's usually just recordings of my live streams from previous terms, so it's not necessarily going to get you useful information step by step as you're going through the course. Okay, so some of the things that we had, we made 2 variables. We'd initially set them up as -1, and we had a little discussion about this, which was they were -1 just so that they were something that was unlikely to be typed in by a human so that we could check if things were working or not. Having said that, we didn't do any checking because we didn't really have time to put a whole lot of error checking in this thing, which is potentially what we're going to do today. So 2 things we're doing is we're reading in the values of the 2 dice. So we're telling the user, well, we're asking the user, because we're saying please, asking them to type in the value of a die, and then we're scanning that into one of the variables. Then we're asking them to type in the value of the other die, and then we're scanning that into the other variable. So this is the basics of printf and scanf. You'll get a handle on it the more you practice, but basically, the printf is really easy. It's just saying that everything in those double quotes is going to be displayed to screen. The scanf, this is the simplest version of a scanf, where it's saying, this is the type of thing that I'm expecting. So I'm expecting a whole number, a whole decimal number, and I'm going to put it into this variable. And the and there is saying, okay, this is where that variable is, so that we can find out, we can put the data in there. The and is actually saying, okay, that variable is a chunk of memory somewhere in my computer, and the and is saying this is exactly where it is. So scanf can just write into that memory and overwrite the value that was in the variable there. Okay, so that's the scanf there. And then a bit of calculation here that says we're going to make a new variable called total, and we're going to add the values that we'd read into those two dice together, and it becomes the total. Just a little check to make sure everything's okay, and also some feedback for the user that's using this. We then print out what the total was. And here is the slightly more advanced version of printf, which says, I'm going to print out this whole string which says you rolled something total, and it's going to put an enter key press on the end. That's called a new line. So the slash there means that we're going to do something special, and the slash n says we're going to press enter. And then the %d is where the number is going to be, and total is the variable for that number. So we're going to grab the variable total and put its number in there. So I think we at least got to this point at the end of the lecture, and if not, you can check out the video for me going into more detail. And then we have an if-else structure here. So if the total was greater than or equal to the secret number, I'm saying the target was met, and that prints out the roll was successful. Otherwise, which is the else, so the else, the curly brackets that are after the else, what's in those won't run unless the if failed. So an if-else says, I am going in one of two branching paths, and I will only be able to take one of those two paths. And that's based on the question here with the secret number. So the else says the result was anything other than the total being greater than or equal to the secret number, and we say the roll was a failure. Okay, so that's the program we wrote last week. One of the potential issues we can get with this program is that we didn't have any limitation on what number the person can type in. So they can type in anything they want to. Let's play around with this. So I'm going to compile this using DCC. So I will run DCC on the file itself, which is dice checker. I'm going to tab complete that, make it easy for myself. And we can also say what the program is going to be that we're going to create with this is our output, which is -O. And I'm going to make it called dice. A lot of the time we do actually call it the same name as the file. So the program's the same name as the file, just without the .c on the end. Sometimes we do that to keep things nice and organized, because chances are the name of the file that we're writing something in is going to be the same name as the program that we run. So we can do it like this. So my DCC file, my DCC command takes in a code file, and then it outputs the program itself. If I do ls, I should now have the program in there as well. So let's run this, and I'll show you one of the problems we could have here. I'm going to tab complete that. Okay, /dice checker allows it to run. Please type in the value of one die. Okay, so we had values from 1 to 6, right? So I could have a 4 here. And then what if I decide I would really like to succeed in this role? Like, I don't know what the target number is, but I would really like to succeed. So I rolled that. I did. It's genuine. I did it, right? And so it's like, yeah, cool, you're successful. Your total was 100,003. So obviously we have a potential problem here in that we didn't have any limitations on this. We didn't have any controls on this, so we could just type in anything we want. So now I'm starting to get around to the idea that yes, this could have a problem. And if it does have a problem, what can we do about it? Let me show you another possibility is yeah, I rolled a 4. And then my friend's screwing with me and thinks it would be funnier if I failed this, so I get a negative 500. And it's like, what? How could I roll that badly? And then I failed because my total was negative 496. Right? So we can see that our program, while a lot of the time, if we did put in the right values, everything was going to be fine. If I start putting in the wrong values, it just sort of turns ludicrous. Right? It's like this isn't even remotely working the way that we expected. So we can think of that as a problem. And the problem we can see immediately is that we can type in values to this program that are not correct dice values, and the program is just happy to do it. Like, the program's just going to continue with it. So let me just go back to my slides. So that's an idea of where we're at right now. So we have a program that can do this whole look at the dice values, add them to get together, and then tell us whether it beat a target or not. The problem that we're having is if someone enters values that are too high or too low, things don't work properly. So if I go back to my problem-solving thing, figure out what's wrong. Okay, we figured out what's wrong. Values too high or too low are causing us issues. Now we need to figure out what our options are. So there's a few things that we can do. Oh, actually, in terms of sort of isolating the problem itself, what we might want to do is look at what the inputs are that the user has typed in and say, okay, can we decide whether their input was a problem or not? And so if we take this code, which is pretty much the same code that I had there, which is testing the input, and we say, how do we figure out whether that input was correct or not? We can actually start doing that by reading in the values and then testing those values against our potential, say, minimum and maximum values of our die, and then saying, okay, were these values legitimate values or not? So one of the issues that we've got is this. We represented our dice as integers. So if I have 6 values of a dice and I only want to accept values in that, the problem I have is, okay, this isn't to scale here, but what I'm looking for is just this. I'm looking for this little range here. And I'm saying I only want to accept values in this, except integers are like that big. There's all these amazing possible values, millions and billions in either direction that we could have, but really what we want is just those little amounts of 1 to 6. Have people seen these kinds of things before, like number lines? I realized I just threw one up last week without really talking about it. This is just like, if we pick any point on this line, it's a number. And so the further we go in that direction, the higher we get positive numbers. The further we go in that direction, the larger negative numbers we get. So it's just a little way of visualizing a system of numbers. Okay. So what we have is a situation where we would like our input to only turn out to be these values 1 to 6. But the possibility for what can be read in by scanf with an integer is much bigger than that. So we have some code here that is going to be able to test our input range. So we could say, this code is the code we have already. Let's read into the first variable, die1, whatever the user types in. And then what we can do is we can start testing it. So we can start saying, is this thing inside the range that we're looking at? And so I was saying before that with our relational operators and our logical operators, we can combine questions. So what I'm asking here is a combined question. Is the number in die1 greater than or equal to 1, but is it also less than or equal to 6? So what I'm saying is it between the values of 1 and 6, including 1 and 6? So I can ask that question there, and I can say, if it is between those, then we have a correct input. And if it's outside of those, we have an incorrect input. Let's add that to our dice checker now. And I'll just put some stuff in there so that we can see whether it's working or not. Okay, so we're just going to work with die1 for the moment. Check input for correct die values. Okay. For the moment, I'm going to assume that the number was typed in correctly and we did read a number, so I'm not going to go into the issues that we can get if scanf doesn't work properly. So, if we're checking for this, we're asking a question, which is if die 1 was between 1 and 6. So I said if 1 is less than or equal to die 1, now I'm going to get, I've said that die 1 has to be the greater than or equal to 1, which means I've said that I'm going to reject all of these values below the range that I'm looking at. Then I'm going to ask another question, and I'm going to say die 1 is also less than or equal to 6. I'm spacing things out, so we're going to talk about this more later. I'm trying to write code that's as readable as possible, so I put spaces in between things here, because if I was to do this and mash it all together, oops, page up by accident. If I was to mash this all together like this, it makes it really, really hard to read. As you can see, like that, it's a bit messy, so I want to make sure I'm not doing stuff like that. So I put spaces in between things, so we can see the gaps in between the operators, being the less thans or equal tos and the ands and stuff like that, and the actual variables and values we're looking at. Okay, so this here, where are we? This here should say I'm looking for a number inside this range. So I said it has to be greater than or equal to 1, and it has to be less than or equal to 6, which means I'll only run the if code if the number is in between these. If it's outside of these, I should run the other code. And the other code is going to be in this else statement. Oops. Okay, in order to see whether this is working or not, I'm going to put some printf statements in here. So printf, I'm probably not going to leave this like this. I'm going to do other possible options, but I want to at least show this running. So printf, I'm going to say roll is valid, and I'm going to put an enter on the end of that. Or printf, roll is invalid. So if I run this, I should now have a program. It's not going to do this for the second die, but at least it'll do this for the first die, and it'll tell us whether our roll was allowed to be rolled, you know. So I can go back in here. Let me just make sure I saved that. I think I have. I'm going to press Control-S just in case. I'm going to go in here. I'm using my up and down arrow keys to go back through my previous commands. I'm going to find my DCC command, and this is going to compile my program again. Compiling the program again is going to create a new dice checker file, this green one here, and it's going to give me the program that I've got, that I've written currently, rather than the one that was previously there. One of the things that we get a lot when we're first starting out with C was we accidentally run the same program, even though we'd edited it, we forget to compile it, we run it again, we get confused why it's not going. Okay, so I'm going to compile that again. That's going to make a new dice checker, so I will run that now. And the value of die 1. So let's just give it an incorrect value now to make sure that it's going. So if I give it a 9 instead of a 6, it's telling me the roll is invalid. So that's a good thing to see, because we know that, oops, didn't want to go there, here. We wanted this to be able to tell us if the roll was invalid. So this if statement has probably worked. I say probably because we only tested it once. There's possibly other ways that it might not be working. But I typed in a value that was outside of the range 1 to 6, and instead of running this, saying the roll is valid, it went to the else, and it said, run what is invalid. So I asked a question about the input that I'd put in, and the question was false, and so it came to this else and said my roll was invalid. If I just, I'll just finish this, run this again, oops, and I give it a value that is within the range of 1 to 6, it tells me that the roll is valid. So I have a reasonable idea now that this little if-else statement that I've put in there is able to tell the difference between whether this role is valid or not. I'm just going to put another value in there. Okay, so now we can test the input range. We've got a decent idea about what is or isn't incorrect. We are able to identify the input that's typed into our program that's causing us problems. What we can do though, and this is one of the fun bits, I said I was going to talk a bit about constants, is what if my die isn't necessarily value 1 to 6, or I want to be able to run my program different times and have different sizes of dice going on. I can do something like this at the start of my program with constants and hash defines. So there's a few kind of advantages to doing it this way. So if I have 1 and 6 in my code here, and then at other times I need to work out things to do with the 1 and 6. I put 1s and 6s all through my code, and so there's like in like a bigger program, there's like 100 different places where I have 1 and 6 in there. And someone says, cool, so you've got a program that works with 6-sided dice. Does it work for 8-sided dice? And you go, potentially. And then you go through your code line by line looking for all the 1s and 6s and changing all the 6s to 8s. And yes, you can do that, but it's really, really fiddly. But if we do the following, we use hash defines instead, and I could say the minimum value is 1, and I can say the maximum value is 6. If someone would say to me, does your program work for 20-sided dice? I can say, yeah, it does like this. If I've written all the rest of my code without the number 6 in it, but using maximum value instead of the number 6, now my program works for 20-sided dice. And I can recompile it for 8-sided dice. Or I can recompile it for 12-sided dice, right? So for the moment, for 6-sided dice, the way to make this work in here is that every time we're referring to the values of the dice, instead of putting a magic number in our code, which can confuse people, we can now put something saying this is exactly what we mean. Oops, that's not going to work. Min value and max value. Couple of bonuses here, right? One is that if I want to change what the die values can be, I can just change my hash defines here. And these hash defines are going to work through the whole program so long as I used the words min value and max value every time I was using the lower or upper limit for the dice itself. The other thing I've added to this that makes it easier for us is I've now made this line easier to read. So I no longer have to think about, oh, what did I mean by 1 and 6 in that line of code? So if I'm like programming this thing and I forget that I'm actually in the dice code, I was somewhere else in like the movement code or the skills code or whatever it was, and I come back here and go, what do they mean by the 1 and 6? Now I don't even need that because I can look at it and say, oh, they meant the minimum value and the maximum value, and they're looking at dice because the variables are die values here. So it's really, really easy to read this line of code now. So what we've done with these constants is not only made it a little bit easier to read, but now if at any point I want to say, I want a different size of dice, all I need to do is change one number in my code. I don't need to go hunting through my code looking for every time I wrote 6 and then change it to a different value. Oh, we have a question?
Let's say you want to have like a different print statement saying, please, type in the value of die between 1 and 6.
Ah.
Refer to your min value and your max value. How would you include that in your print statement?
Cool, that's a really good question. So the question was, if we were saying something to our user saying, please type in a value of a die between this number and this number, can we actually do that in a print statement? And the answer is yes, we actually can. So we can treat this min value and max value the same as we would a variable or a value. So I could do something like this. Please type in the value of die 1 between, and I know that these are decimal numbers, between this and this. I'm going to have to probably go to the next line here. But I can say, remember, if I put 2 symbols in there, I'm going to need to give it 2 values. I can do this. min value, max value. Sorry, I've just had to jump to another line, so I'm just going to neaten this up a bit. Just going to tab that in there for the moment. Okay. This is actually going to grab whatever values are in min value and max value, and it's going to print them out to the screen. Let's run this, because I think this is interesting to see. That was a really good question, by the way. I like that one. Okay. Let's compile this again. Where are we? Compile. And then run this. Please type in the value of die 1 between 1 and 6. So you can see it's picked up the values we defined using those hash defines, which is here, min value 1, max value 6. And we said min value is the first number, max value is the second number. And then what our user sees is this nice thing saying between 1 and 6. So let's give it a 5, and it's telling me that roll is valid. And a 3, it's not checking whether the second roll is valid because I've only put checking code in here for die 1, and I haven't done anything to the code for die 2 yet. Let's see this changing. So let's say I wanted to use a 20-sided die instead of a 6-sided die. I'll save that. Sorry, we've got some questions before I go on.
So you use the decimal at, right?
Yep.
So, like, does it detect that it's an integer and save it to integers, or like?
Oh, the question was, I used decimal as in %d in here. And the question was, is it going to see that thing as an integer or not? See, the interesting thing about hash defines is they don't have a type. They're like a pure text replacement. So what it's actually going to see it as is if I had, for example, typed in the number 1 there, C is going to automatically detect that as an integer value because I haven't put a floating point onto it. So it's going to say it's an integer, not a floating point number. We had another question behind you, yeah?
Yeah, so even if we put in an invalid number,
Yep.
the program still runs to the end and we still have to type in the other value.
Yes.
So can we just like sort of do something like when we put in an invalid number, we just end the program right there and just...
We can. You're spoiling my next slide. It's actually in the slides later, yeah, totally. But yes, that's definitely a good option. So the question was, if we type in an invalid number, this program is still running. So we type in an invalid number, the program's still adding stuff together and it's still calculating and everything like that. Shouldn't we be doing something about it if we've detected it's invalid? The answer is definitely. But the trick is that there's many things that we can do. And that's going to be discussing our options, which I'll get to probably after the break, because we're about to go on break. But yes, I do actually have slides for that. So if you are looking in the slides ahead, which you don't have to do, obviously, that does show that. Okay, so we're going to, I was going to show this working. So if I change the maximum value to 20, so now I've crossed over to a 20-sided die, I'm going to save this and compile it. Run it again. So I'm just using my up arrow keys here to get my old commands back. Please type in the value of die 1 between 1 and 20. Right? So now we've converted it to between 1 and 20. And the other thing is, because I changed the constant, if I type in a number that's between 1 and 20 now, like 19, the roll is now valid. And I only had to change the number in one place. I didn't have to change the test to see if the number was valid, because in that test, I was using max value. And if max value changes to 20, it changes here and here. So that's like one of the nice things that we can do with using constants like that. All right, let me just finish that. Don't want to leave it running in the background. Okay, so we're going to take a break for 5 minutes. I have some trivia here about dice. So apparently the first 6-sided dice were excavated somewhere in Iran and dated back to approximately 5,000 years ago. Okay, so we'll take 5 minutes. We'll come back at 10:05 and I'll continue with our problem solving and our dice checking program. Hey, Mike. Did you want to talk to people?
Yeah, can I put I've got a video. Will the audio work?
Maybe.
Okay, can I like put in this link?
You need to give me a link?
Yeah.
Okay. Go nuts. Do you need a microphone?
No. As long as the audio works, it'll be fine.
As long as the audio does work.
Yeah.
That's at 100. Source volume is unmuted. Let's see if it works. I think I heard something.
Okay.
All right. Go nuts.
You want to play it?
Do you want to get their attention first?
Sure.
Or?
Yeah.
Hello all. Michael here, who is probably one of your lab assistants, works with CSESOC, and he has a video to show you about CSESOC. So hopefully the audio works on this. We haven't tested it, but we'll try it now. Yep. Actually, you should talk to him. Yeah. I was going to say, do you have a link? You have a link, yeah.
Thanks for that.
No worries. Camp would be a good place to meet people and stuff. It's good. You can hang out with him there.
That's all I got.
All right. Cool.
Yeah. Oh, just briefly, I also sent you an email about workshops in week 6 if you want to do something.
Ah, yes.
Yeah, so yeah.
I'll get back to you. Yep. Hey, how's it going? Yeah. Ah, I can see you've written heaps of code there. That's cool. Ah. Yep. See.
And because I've written the true low one first, so you do a true high, and then you do a true low one next.
Yeah.
How do I do it so that we run at the same time?
Wait until tomorrow.
Okay.
Tomorrow, I'm going to show you how to repeat code. And so you'll be able to use that code to check for too low, too high, and then go back and check it again, and then it'll work. But wait till tomorrow. I'll show you a new construct tomorrow, and then come back and let me know whether it worked or not. Because I reckon you'll get it, because I can see already you're editing things and getting to work. But tomorrow we're going to look at looping, and that'll help that. Yeah, no worries. Hey, oh sorry, I think you were asking me a question.
Yeah,
Sorry, she was here a second
my
ago.
VLab just shut down.
Oh right.
I was
Yeah.
going to show you something that now it's not finding the file. That's okay.
Okay, no worries. Yep. Hey.
For this stuff, how do I move it into a folder?
So if you want to move something into the folder, it's the MV command. So you move, and then you type in the name of the thing you want to move, and then you type in the directory you want it to go into, and then put a slash on the end, and then press enter. Okay, now if you go in there, or if you just have a look, you'll see that it should be in there now.
Yep.
There you go. Awesome. Hey, how's it going?
For this, why did you put -1?
That was just on the possibility that it didn't get read in properly. We'd have something really obvious to see that it wasn't working. Having said that, you could just type in -1 and cause all kinds of problems with that. It doesn't really do anything. It just means that the value of this is -1 until it gets overwritten by something else. Yeah. So it was a just-in-case thing rather than a genuine thing. Yeah.
When you do a function,
Yeah.
try to make a function and see the output name.
The int is saying what the output of the function is. We'll get to that though. We're going to talk about functions probably next week. Yeah.
Like we have to put int to say hello world.
Yeah,
Is
yeah.
that for the 0 at the end or something?
Yeah, that's just for the 0 at the end. Yeah.
So is that for everything you have to anything?
Main functions are always int, but other functions will be different. Yeah. Okay, I better get back into it. Sorry everyone who has questions. I've got to get going again. But come afterwards, and I'll talk to you afterwards. Yeah. All right, let's get going again. So, where we're up to at the moment is we've set up some constants, and the constants are allowing us... Thank you. It's always hard. There's a lot of us in here, and the break is short. The break has to be short because I don't have that much time with you anyway. But I don't ever want to lecture for 2 hours straight without a break because all of our brains will explode, mine included. So, okay, so we've added some constants here that give us a minimum and maximum value, and you've seen how that can be quite useful so that we can actually change those values without having to go through our code and make changes. Also makes things a bit more readable. So, following on from our point down the front here is, what do we do if we get invalid code? So this is exactly, I think, what you're thinking about. So, what can we do if the input comes in invalid and we don't understand what it is? We can panic. Although I don't even know what a program does if you say panic. I guess we could just not deal with the problem. And we could just have these massive negative values or massive values come in and we still let it happen. That's actually where we are at the moment. At the moment, we're just letting these values through. Even though we're saying they're invalid, we're still letting them through and we're still calculating with them. So this is the option that was given to us from down the front here was saying, shouldn't we maybe reject this? And shouldn't we maybe end the program here? And so that's not necessarily a bad idea. If this is a program that's meant to take valid input only, maybe we should just say no. You're not supposed to type that in. This program ends here. Sorry, goodbye, thank you very much. But there are other options here. So there's other things that we can give our users. We can say to them, we can let them know. So at the moment, we are saying whether the input is valid or invalid. We could actually let them know exactly what the valid and the valid or invalid values are. Say that 3 times fast. Or we can do other things. We could ask for new input instead. Or we could go in and we could correct the input. Actually, the asking for new input's a little bit difficult with the vocabulary that we have right now. I am going to take you through stuff tomorrow that we could do for asking new input. But for today, we do have options for correcting that input. So what I'm going to do now is take you through that whole kind of possible process of problem solving by saying we have a problem, we are able to identify the problem. So we've gone through and we said, okay, we can tell for sure whether the value is valid or invalid, and for different sizes of dice, because we've set up our thing to say, okay, can be 1 to 20, 1 to 6. We could have a die that rolls 3 to 8 if we want to. I mean, it's a little bit messy, don't exactly know how that works, but we could if we wanted to. But what we're going to do is we're going to stick to sort of standard dice sizes for the moment, even just use our 1 to 6. And we're going to look at the different ways we can deal with the possible output. So one option is we reject the output entirely. So here's some code for it. Don't worry too much about the code in the slides. What I'm going to do is actually write the code with you in VLab here, and we'll see how it works. So where's my cursor? There. At the moment, I'm just going to do my code for die 1. I'm not going to bother checking die 2 for now, because what I'm going to do is sort of wait till I've figured out exactly which solution I want to and then implement that solution for both die 1 and die 2. Okay, so we had our ability here to say whether the role is valid or invalid. So if I want to, I can say if it's invalid, I'm going to take the advice that I was given earlier, which I so rudely rejected, but now I'm on board with you, is that if it's invalid, we don't want this program to finish, right? There's no reason for this thing to continue with like a 9999 obviously cheated role in it. So what I'm going to do is I'm going to end the program. So I'm just leaving a comment here to remind you of what this thing is going to do. I'm going to do a return 1 here. So return is an interesting thing. I mentioned it briefly previously that return was going to end the program. And return 0 was a really standard thing that people use in C. Return 0 says no problems. So often when we finish a program, we will say this worked, but we could give a number other than 0 to say that this program is ending in a way that we didn't expect it to. So it's ending in a way that's incorrect. I'll type in a code here that I don't know how much people see these things, but you may recognize this. So if I was to say 404, people have seen, yeah, I love that, that's great. Okay, people have definitely seen this error code before. So sometimes it's a bit older now. I don't think they necessarily show it to you explicitly on websites. But if you look up a website and it doesn't exist, you usually get what was known as a 404 error, which is the program that's running, that's serving you web pages, says, I don't have that web page. The error code for this is 404. So, for example, here, I can return an error code. I'm just going to use 1 because it's different from 0. And the 1 is saying that I received an invalid input. We don't use these very much anymore. This is kind of a historical thing where we used to have error codes for stuff. Nowadays, we like to give errors that have more information than just a number. So nowadays, we would probably want this thing to say something rather than just say error 1, deal with it. And then you have to go looking up what error 1 is. So error 404, the first time you see it, you're like, I have no idea what's going on here. But after you've seen it a few times, you sort of start to recognize it. So what I'm doing is saying, I'm not doing this. I'm not saying return 0. So return 0 I've reserved for a situation where I think that this program has run correctly. But if I think the program hasn't run correctly, I want to give anything other than 0 to at least say, okay, slightly different. You don't have to worry too much about this kind of thing, and it's not even the kind of thing we're assessing, but it's nice to know about in case you do see programs that want to return with different numbers. The key, however, is not necessarily the number, it's the fact that I used return. So return on both of these says this program is over. So you know I was saying, when a program runs, it goes line by line. It just goes vertically down the code. And it says, I run this, then I run this, then I run this. If there's an if or an else, I might jump to a different part of code. But I don't go back or anything like that. I just keep going down. The trick with this return is once I hit this return, I will not continue going down line by line. That's it. Program finishes there. It stops. Nothing else is going to happen. We can see this running in a second. Let me just save this and compile this. So I'm compiling again, running. If I give it a valid value, say 5, roll is valid, it continues, I give it another one, 6, successful, right? So this is the behavior we're expecting from this program. Now, if I give it an invalid value, so let's say I give it a -50, which is outside my range of 1 to 20, it says roll is invalid, and then I'm back at my prompt there that allows me to type other things in. You can see that the rest of the program hasn't run. It didn't ask me this for the second die. It didn't do any calculations or anything like that. So what's happened here is when it's invalid, it was outside the range of the minimum to maximum values. The roll was invalid, and it says nothing. End program here, return. You don't even get to see what the return value is of the program. That would only be if another program was running this program. But what we get is none of this continues. So what we've done at this point is we said, okay, I reject your input. Human, you are incorrect. I reject what you're doing. I refuse to continue serving you. All about our evil robot overlords. Okay, so we have this possibility. We can reject the input. Question over there. Yep. Yep. Yeah. Okay, so the question here, or the kind of something we're thinking about is, when running the Hello World program in the lab last week, sorry, what was your name? Sorry? Pattis. Oh, Paris. Right. Okay, cool. Sorry, I just didn't hear that. Yeah, so Paris said that he changed the return to a 1, compiled it and ran it, and it still worked. So the return value doesn't necessarily mean anything unless we're going to read the return value and try to get something out of it. So if we had another program that was running your Hello World and it was saying, okay, did this work or not? Then it would actually read that value. But as it is when we're running it in the terminal, it still just finishes. So as you can see here in our terminal, we didn't actually get any information in particular to say whether it had finished correctly or not, which is why the return codes, we don't really use them that much. We could have just done a return 0 if we wanted to. I changed it just because I prefer at least trying to stick to some of the old conventions that used to be there. Okay, so yes, it doesn't specifically matter to us as humans what this return code was. So maybe it's not a bad idea to actually give some more information to the human, which is also in the slides coming up. It's either I wrote these slides amazingly or you guys down the front are really like clued in because you keep telling me what I'm about to do in the next slide, which is really cool. Okay, so I can reject the input and let's have a look at that. And we're already starting to think about this. How do we feel about this option in solving our problem? So I could say that yes, this guarantees to solve our problem because there's no way that an invalid input can continue to the point where it's calculated, right? So if there's an invalid input, the program just goes, bam, nothing. I'm not going to give you anything, GG, no re, etc. See if people got that? People don't say no re anymore. They say GG or they say like, what, GGGL, right? Good, or GLHF. Nowadays, right? So we've got some. Sorry? Oh, GG too easy. GG easy, right? That's like. I mean, like, I was about to say you people are meaner nowadays than we used to be, but we were just as mean. Because GG no re meant good game, no rematch. Where you're just being an asshole and you're just going, nah, I've already won, I don't have to play you again. Anyway. I apologize. I used to have this idea that, like, you know, every classroom only has room for one clown. So if I'm the class clown, it makes it really easy because I can control them then. Except I can't. Okay. So what we have is a program that's actually being that level of douche to you. So it's just saying, nah. And it's not even giving you any information. It's just shutting down on you. And what we would probably prefer is that maybe we should think about what we would want to see if we were using this program. So if I'm someone sitting there and I'm rolling my dice and I type them in, but the program just doesn't run, then I'm missing out on some useful information, right? So maybe what we want to do is at least give our users some useful information to say, this is why this thing isn't going to continue from here. So maybe let's report the failure. So let's give the user a message to say, okay, this didn't work and there's a reason why this didn't work, rather than just return 1, goodbye, you know? Because at the moment, I mean, it did say roll was invalid, but previously while we were running this thing, even when the roll was invalid, it still kept going. So maybe we want some more information just to tell people what's going on. So I could say, roll is invalid, program will exit now. So now it's not a shock. It's actually said to us, because you gave me an input that I couldn't use, I was forced to stop. And then that way, at least the person can say, this isn't unintentional, my program isn't broken, there's nothing wrong with my computer necessarily. It decided it was going to stop, and it told me it was going to happen. All right, so if we save this and compile it again, compile and run, and I give it another invalid die roll, it'll tell me roll is invalid, program will exit now. So I can understand this now, right? I can look at this code, I have it running, and it will say, I'm not going to continue. I can't continue working under these circumstances. This is it. Flip the table, walk out of here, right? That would be really bad if I flipped that. That's got all the audio visual stuff in there. End this lecture very quickly if I did that. Okay, so but the program at least is telling us that. So it's not telling us that there's been a failure in the program and it's accidentally crashed or something. It's saying this was intentional and it's your fault. So at least now we have some information. So here we can say, okay, ooh, this one was even more. We could actually say what the value was that was out of range. So we could do that as well. Oh, we won't bother. We're just going to move on. We've got other things we can do. But can we do a little better than that? What are some other options that we have here? So we could, if we want to, give the user some more information. So we could say to them, what are the actual values that would have been correct or not, so that when they run the program again, they're more likely to get it correct. Because this program is really very much based on interaction with a human. So it's based on a human rolling a die and then typing a number in. So if we want to help them, we can say, okay, this is the situation. We can even do better than what I've got on my slide here, because what I had on my slide was before we had a conversation here earlier about actually outputting the minimum and maximum values. So I only had the numbers 1 and 6 in here, but I can probably do better than that. So what we might want to do here as we're exiting is say to the person, this is what you rolled, this is the minimum value you could have rolled, and this is the maximum value you could have rolled. Try again, you know? So let's do that printf statement. It's going to be a pretty big printf statement, but it'll show you how we can do something like this that might give us some more information. So what we're doing now is, actually, let's go back to, where are we? Problem solving. We have figured out what's wrong. We have several possible options, and we've tried one of those options. And as we've tried that option, we've actually been bouncing back and forth between 4 and 5 here. So we had an option to reject the input entirely, stop the program, and we tested it out and we said, okay, it sort of works. And then we thought we can make this a little bit better. So we go back and we try a slightly modified option and we check it to see if it's better. We keep going back and forth there until we get something that we like. So where are we? Here, we're going to report some information. So we're just sort of adding to our solution to this problem to make it a better solution than what was there before. A lot of the sort of most important, biggest programs that we use day to day are constantly going through this process. So, I mean, using something like, just like what do people use all the time? Like an email client. Who here uses Gmail? Do people use Gmail? People are still using a lot of Gmail, right? Yeah, okay. So a lot of people are using Gmail. If you've noticed, every kind of 6 months to a year or so, Gmail just changes a little bit. So that's people going through this exact process where they're saying, what information did people need? What are people clicking on more than other things? What are people reporting to us the most about the problems of how to use this? And then little parts of the website will just sort of move around and things. And like, so for those of us who get really used to it, it can come as a shock. It'll be like, where's the button? The button used to be over here, but what we don't realize is that Google's tracking all the mistakes that people are making in it, and they're trying to shift things around to make it better. So they're going through this constant problem-solving process bit by bit over the years to try to make their product as best as it can be. We're doing the same thing here when we're problem-solving. We're saying, okay, there's a problem of incorrect input. What are all the things that we can do to make this better? As we look at all the ways that it can go wrong and all the ways we can make it better, And then having made something better, we may cause other problems and we try to fix them as well. So it's a kind of like an ongoing process, solving problems. Okay, so instead of this here, I mean, I might leave the program will exit now there. We're going to give some information to the user. So we're going to say, this is what you rolled, this is the minimum and maximum value. So this will help you the next time you type in a number to get it correct. So roll of something was, I'm just making this up as I go, was not between something and something. Program will exit now. Okay, let me just get myself some more space. One of the nice things about our code editor is it has this vertical line here. So it's a bit subtle. This little vertical line here says, once you cross over this, it's going to be hard for people to read it. So I just had to widen my screen a little bit to fit this line on. And I'm not even finished with this line, because I put 3% Ds in there. So if I put 3% Ds in there, I'm going to need 3 variables, or 3 values, to put in there. So what I'm going to need to do now is split this onto multiple lines. So I can do this. Oh, you know what I can do is I can actually start splitting this onto multiple lines the same way I would an if or else statement. So with the if and else statements, I open my brackets and I close my brackets, and in between, everything else is indented. And the indentation allows me to remember what's inside or outside the brackets. So what I'm going to do is the same thing for my printf here. Push this down to a near line and indent it. And I've got 3 variables. So the role of something, so this is what the user typed in, which is going to be die1. And then was not between something and something, so I want min value and max value. So min value max. I'm going to autocomplete that max value. Okay, so now I've got what used to be 1 line, but it was going to end up too long. Because what happens when we have really long lines is the way that we tend to read code is just vertically. You know, we go line, 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 line if we're reading it. If a line gets too long, it sort of goes off the screen and we'll miss things. It's really easy to make mistakes the longer a line is. So this one here keeps stuff like these variables. Let me show you if I don't do it. Got that. That. And that. And I'll turn word wrap off. Where is word wrap? Is it in the view? It'll be in here in the preferences. Yeah. So if I am just using this and I don't have the word wrap in the window on or anything like that, and I have a long line, one of the issues I have in reading this code is I can't see what variables are going to be printed out because I've just made it too big. So that's the reason why we might split something onto multiple lines. Okay, I'm going to put this back. I'm going to Control Z. This is going to undo these changes I just made. There you go. And if I do it on multiple lines like that and I put the brackets vertically aligned like that, it's really easy for me to see where the brackets open and closed. So the closing bracket is aligned with the word that opened it. We'll kind of get into this more as we go along. I'm going to talk about the things that make code more readable and more usable for humans. I might fit it in next week. We'll see how we go. Okay. So now when we're exiting the program, we're not even just reporting that we're exiting the program. We are also reporting exactly why the program exited. So what we're doing is we're basically just becoming more and more polite to the human that caused the error as we go along. So the very first time the human caused the error, the program just disappears. It just totally ghosts them and just like, that's it, done. But now what we're doing is we're putting more and more information in, so the human's less likely to just completely make the same mistake again. So let's save this, compile it, and run it. And I'm just going to put an invalid value in here, and we'll see what it does. So I'll put a 21. So I'm only just outside the range, but, you know. Roll of 21 was not between 1 and 20. Program will exit now. Okay, so now we have a completely different response from our program than we had before. Before, the program was just like, boot, you're out, don't care. But now the program is saying, this is exactly what went wrong. So you should know now for next time how to fix that problem. So I should be able to look at this now and go, okay, I gave it a number that was outside the range it was looking for. Now, the next time I go in, I should be able to do a bit better with it. So a lot of this stuff, note that what I did there, that whole sequence of problem solving there was not even fixing code. It was fixing the way our code interacted with humans. Because most of the time our programs are going to be used by people. I mean, sure, there are some programs that aren't specifically used by people, but most everything we're going to do in computer science is going to serve humanity in some regard. Like, we're going to make a product that we want to sell to people, or we're going to make a service that's going to make people's lives better in some way. So everything that we're going to do has a sort of a human aspect to it. So we can spend some time with problem solving to make it more useful for humans. And generally, every program we write has a purpose that's dictated by humans in some way. I said humans like I'm not one of them. Robot lecturer, people. Anyway, so a lot of our code is going to be that. A lot of our code is going to be, yeah, it works, it functions, it runs properly, but it doesn't really fit the needs of the people that want to use it. And so we will adjust it so that it does. Okay. So that's one thing that we can do. There is another option though. And this was one on my set of options that we were looking at originally. And it is the option to correct the input without exiting. So what if we say, you typed in a number that was not correct, but what I'm going to do is correct it so that it looks like a correct dice value, and then we're going to run with it anyway. So what if I have a commitment in this program that I'm not going to exit, I'm not going to kick the user out, but I'm still just going to make it work? So there are two options here that I'm going to use. One of them is called clamping, which means that like I have this tiny range of 1 to 6 and all these possible values. What I'm going to do is anything that's outside those values, I'm just going to push them until they're inside the values. So I'm just going to push the numbers in so that all the numbers possible just go into the range 1 to 6. And that's going to have some possibilities for us. And the other thing I'm going to show you is a modulus, which is potentially a very elegant solution to this problem. You can tell I've solved this problem before and I've already picked one of these solutions, right? They didn't call any of the others elegant solutions today. Anyway, but we'll get to it. Okay, so clamping's the first thing we're going to do. And what it's going to do is it's just going to say, if you're outside the range, I'm just going to push you until you're inside the range. So what I'm going to do is I'm going to grab the values and I'm going to say, if you're incorrect, I'm just going to force you to be correct. So I'll show you this code. You don't need to really look at it on the slide. So I am now no longer going to end the program. I am now going to write some code that corrects the input instead. So what I will do is I might just comment out this section. So I've put these are the types of comments I can do to say, okay, everything between these two symbols is not going to be the code that's run. And I'm going to start writing some other code instead. I will leave that in there though for you so that you can see it. So if you want to look at these ideas of like sending a message back and ending the program, this will still be here. But otherwise, I'm going to write some other code. So if I want to correct the input and I want to say, if you're above 6, well, I think we're 20 at this point. If you're above 20, you just become 20. Wait, that's this side for you. I'm thinking in my head. So if you're above 20, you just get pushed down until you're 20. If you're below 1, you just get pushed up until you're 1. And so any values we put outside the range just get forced into the range, and that's how they are. So, as I said, up here, if the input value, which was die1, is less than the minimum value, which is probably going to be 1, but you know, I'm still flexible in my code if I want to change the hash defines to be something else. So if it's below the minimum value, I might put a comment up here actually. Below minimum. Often like to put little comments in there to just remind myself of what is happening at this particular point in time. If I've gotten into this if statement, it means something has happened. So I've just put there saying it's below minimum. Then if it was below the minimum, I'm going to do this. So I'm saying any value that was below the minimum just gets turned into the minimum. So this is like me taking the entire number line, all the negatives and stuff, everything below 1, and just pushing it until it gets to 1 and go, okay, that's what you're going to be now. I've changed your value. You don't get what you rolled. You get what I tell you is a legal value, which is there. There's another option. We could do this as an else. We don't even need to do it as an else. I'll show you another way we can do this. We can just do a completely different if statement. It's probably better to be an else because there's no way a number is going to be below the minimum and higher than the maximum. But it's not, actually, you know what, I am going to make this an else because it's really only going to be one or the other because you're either going to be higher or you're going to be lower. Okay, so if die1 is greater than the maximum value, I'm going to say this is above maximum. Then I'm going to say you do not get what you typed in anymore. You get what I'm giving you, which is a value that is valid. And the maximum value is the closest value in my range of the dice to the one that you typed in. So now what I'm doing is I'm forcibly correcting the value of the dice, and I'm saying no matter what you type in, I'm going to give you a value that's correct. Let's have a look at this running. Okay, I'm going to compile that, and then I'm going to run it. And I'm going to try some of my previous shenanigans to try to cheat my way through this roll, and I'm going to put in like 400. And it's like, okay. So at the moment, we actually have taken a few steps forward and a few steps back, because we've taken out all of the information that we put in there to say, okay, this is what you did wrong. All we're doing is just doing something. So if I think the other one's going to have to be valid. So between 1 and 20. Actually, we're not doing any checks on die 2, so who knows? So note now that my total was not 405, so it didn't take the values I typed in. What it did is it said, you tried to put in a value that was way higher than 20, but the biggest value I can possibly give you is 20, so that's what you're going to get. No more than that. And so my total is now a valid total, because the die that I tried to roll as a 400 got pushed down to 20. So what it's done is it's come through here and it said, you were greater than the maximum value. Random space in there, I'm going to fix that up. You were greater than the maximum value, and that was not going to be a valid value. So what we're doing is we're changing that to the maximum possible value. And so that way, what we're doing is we're forcing this to be valid no matter what. Are there any issues with this? There are potentially some issues with this. We will get input that works, right? Because we're saying, no matter what you type in, if you're above the maximum, I give you the maximum. If you're below the minimum, I give you the minimum. If you type in anything in between, you'll get what you typed in. Question up the back there. Oh. So the question was, how do we deal with input with scanf that is not a correct number? So it isn't like a decimal integer that we're expecting like that. I apologize and say I don't have time to answer that question right now, because answering that question involves part of the C vocabulary that we haven't taught everyone yet. So scanf, I'm going to give you a hint, a spoiler for the future, and this isn't that much of a spoiler because we're going to talk about it probably next week, is that scanf is what we call a function, and a function has the ability to give us some information back. scanf, if it doesn't work, will give us some information back. And that's like those return values in the main function that we're doing. It's actually giving information back. Another question up the back there.
Would there be overflow and underflow issues with integers?
The question was, will there be overflow and underflow issues with integers? Potentially. The clamping, are you talking about the clamping solution that we have here? It will probably be okay because if it's anywhere in the scale lower, we're pushing it up to the minimum. And if it's anywhere in the scale higher, we're pushing it down to the maximum. But since we're just pushing it inwards and we're not going off either end, we'll probably be okay with that. Because we're not sort of physically pushing it, we're just resetting it to that value.
Not specifically for this program, but
Yeah.
if we ever do happen to enter an integer that's above, it will overflow to a negative, and that negative will remain until the 1.
Yeah, we could definitely do that. Yes, and that definitely could be a problem. So if I was to type in, actually, let's try it. You know what I'm going to do is I'm just going to look up the value. So 2 to the power of 31. This, if you recognize this number, this is the maximum value that we can have for an integer. So if I take that number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. I'll show you something. Okay, so we had 10 digits there. If I put in like 11 digits, wait, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I am now typing in a number that is bigger than an integer, which means this is likely going to overflow into a negative number. Let's see what value we get out of that. The other one's just going to be 5 again. Did I type in the right number?
Pretty sure you overflowed it 5 times.
I overflowed it too many times, didn't I? Oh yeah, I did. So it's gone back to positive again. But let me type in a number that's only just going to overflow it. Okay. What was it? It was like... Okay, so that'll just be a little bit over because it was 2.5... Where was it? It was 2.14 blah, 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 blah. So this should be just over because I've taken one of the zeros out of it. Let's see if this does it. Yeah. So I've typed in, that was from the point up the back there, it was, are we going to get overflow and underflow value issues with integers? We could. So if I get really, really flagrant in my cheating here and I decide to go really, really high, I could have an issue where I went so high that after the number gets read in, it goes off the top of the end of the integers, comes back on the bottom end of the integers, and ends up a really large negative number, or just a negative number of some kind, and then it got clamped to 1 instead of getting clamped to a really high number. That's not actually the only problem with clamping. So, go back to my slides. The issue with clamping is now we may have changed the sort of statistical way that a die works. The way that we expect a die to work when we roll it is that every number that you could roll on that die is equal likelihood to come up. But if we were to just type in a whole bunch of random numbers in as integers now, everything that was higher than 20 or lower than 1 is going to come up heaps. And the numbers like 2 to 19 in the middle are going to come up really, really rarely because we're just typing in random numbers. So what we're going to get is potentially, if we were doing this in a statistical way of just typing in random numbers and getting it to generate something, we would be getting very skewed results. We've also sort of gone backwards a little bit in that now we're still not telling our user anything. So what we can do is we can definitely give the user back some information saying the roll was invalid, we're going to correct it. But I want to show you another way of correcting these things, which is to use mod. So mod is really interesting because mod is going to give us a remainder if we divide a number. So if we divide numbers that we type in, then we're going to get a value that is the mod of it, which is the remainder if we divided, say, for example, here, if we do a mod 6 on any number, if it's divisible by 6, it gives us a 0. Because if a number is divisible by 6, it has no remainder when we divide it. Otherwise, it will give us a remainder, which is a value of 1 to 5. So, if I do mod 6 on a number, there's only 6 possible values that I could get out of that. That's not entirely correct, by the way. I'll tell you more details as we go along. But I will most likely be getting these 6 possible values out of it, which means I have 6 possible values the same way that the die has 6 possible values, or ours has 20. You know, either way we want to use it. So if the 0 can get converted to a 6, then I get the range of 1 through to 6. And then I get exactly the die rolls. And I can convert any incorrect number into something that's in the range by, instead of taking the number, I take the mod of the number. There's some code here that does that. So what I'm going to do now is I'm going to go back and I'm going to replace the clamping code, because the clamping code was a solution. But it's not necessarily a solution that I like, because I think that there's other things that I can do that might be more interesting. Okay. So if it's below the minimum or above the maximum, I actually don't need that anymore. I'm actually going to get rid of this. Code's in the slides. So, no, I'll be nice. I'll leave it there. It's a bit messy, but I'm going to leave all the possible solutions here. What I might do afterwards this afternoon is like make multiple files that solve the problem in different ways. Okay. Oops. So if I have this, if I'm in this else here, then I know that I've got invalid input. If I've got invalid input, I want to fix it. I'm going to try fixing it with mod now. So what I'm going to say is that die1 could be outside the range. If it's outside the range, I want it to be a number that's within the range. I'm going to replace die1 with the remainder of if I did a division with die1 and the maximum value. I'm making some assumptions here. I'm making an assumption that the minimum value is 1 and the maximum value is a other number. So if the minimum value was not 1, I don't think this solution would work. It would cause weird issues. But what I've now done with this one line here is, instead of die1 being, say, 1,000, it's the remainder if I divided 1,000 by my maximum value. So it's going to be now within a range of 0 to 1 less than the maximum value. Which means it's pretty close to being a die value. If we want to, we can actually just test this. I'm going to actually put a proper message in here, and I'm just going to say corrected invalid value to and I'm going to give it die1. All right, so let's just run this as it is, and we'll see what we're getting out of some of the incorrect values. So I've saved that. I will compile that and run it. So the value I'm allowing is between 1 and 20. Let's say I put in a 25. Corrected invalid value to 5. So now my die1 has been corrected to a 5 instead of a 25, because if I was to divide 25 by 20, the remainder would be 5. I'll just put in another value there. Let's run that again. And wait, that y is going to cause us problems. Okay, I've just put in an arbitrarily high number there. So I've just mashed the keyboard and let the number come out as it is. And it's corrected that to a 16. So what I'm getting now is I'm getting something that is going to give me a value that at least, it's not entirely correct yet, at least is a remainder of the division there. So now I can start typing in just wildly outlandish values, and the mod is always going to bring this down to a value of the remainder. The only issue I'm going to have here is if I do this. So let's say I type in 60. The remainder, if I divided 60 by 20, is 0. So I now have the capability of having 0 results, which is not good, because the die is supposed to be 1 and 20. So I just need to fix that little bit, and I should be able to correct these values. So I'm just going to put a 1 in there. So I've got it to the point where I can sort of ignore whatever value the user types in, and I say I'm using mod to put that within the range at the moment of 0 to 19, but if I want to make it 1 to 20, I can just convert that 0. So if I get the case where the result ended up 0, so you can see I'm doing this if after I've converted it. So after I've converted it, I'm going to get 0 to 19. If it was a 0, if that equals 0, then set it to the maximum value. So what I'm doing here is I'm saying, first thing, you are not the value, you are the remainder of the value if it was divided. That pushes us into the 0 to 19. And then the 0 is not a value of the die I want, but I want a 20, so I'm just converting the 0 to the 20, and then I have 1 to 20. Question over there.
Is there anything wrong with just adding a +1 in the top line of writing?
The question was, is there anything wrong with adding +1? So I could just do die1, mod, max value. Let me just do that up here. +1. There's nothing wrong with that, because that's still going to get us the range of 1 to 20. So it's going to take all the values from 0 to 19, bump them up 1 to get them to 1 to 20. In fact, I like your solution more because there's less code going on. Although sometimes less code is like harder to understand, but I still like your solution. It's very nice. Say again, sorry? So a question here is, if we just add 1 to everything, are we now confusing the user? Because they're not going to get the number they typed in if they did it correctly. They're going to get 1 higher. So maybe it's better to do the mod approach, because the mod approach is going to preserve a correct answer rather than modifying it. So I like what's going on here, right? So we're thinking about the solutions to problems, and then we're thinking about what effect those solutions have. So that was a nice way to clean up the code, except when we take it back to the human, maybe it confuses them. So I'm going to go back again and return it to this one. This is also the nice thing of having 500 people watching you while you're coding. Like, it's really easy to not make mistakes like that. A question over here? Oh, okay, counter to that. The correct role will never be affected here because this is in the else block. So this will only happen if the code is being corrected. So we go back again. We totally can, right? We can go back here and we go, yeah, we can do a +1 here because it was invalid already. So if it was invalid, it was outside the range. We can do anything we want with it at this point. So what we're saying is, if you type in a number that's outside the range, I'm going to give you some value between 1 and 20. And it won't necessarily match up with the number you typed in. But the nice thing about this response is we're going to get something that is it's going to feel like a randomized value. So you can type in any number you want, and it's nearly like it rolls the dice for you and gives you another result. We had a question up there, did we? No? Oh, yeah. No? A question down the front then? Oh, the question was, what happens if the user inputs a letter? We're going to look at that later. So we'll look at weird stuff for scanf later. For the moment, we're going to assume that scanf works until we learn more about it. Okay. So now, if I save that and compile it, and run it, we have our dice checker, and I could do this, and I just get corrected to a value that makes sense. I'll do that again. Oops, I started typing before it was finished. That's okay. And it's going to give me another value. So one of the nice things about this is we can get a value that makes sense to us without having to think about it. But if we type it in correctly, we're also going to get a correct value. Question over there?
What happens if it's an instance where you put in a negative number?
We haven't looked at that yet. But a negative number will mod differently. the remainder with a negative number is going to end up negative. So that's something I didn't look at because I knew I wasn't going to have time. But there is a way to flip that as well if we need to. Okay, so just one thing before you go. What I wanted to point out today, which I think is useful, is that there are many solutions to every problem. And it's about figuring out which solutions you want to use. All right, see you tomorrow.